Alright guys, welcome to our next series of videos. Today we're going to be looking at polygons. And when we think about polygons, it actually kind of makes sense if you think about the prefix poly. And then the gon, it's just something that's kind of just there, it's kind of an odd thing. When we look at polygons, poly is a Greek prefix meaning many. So a polygon is a shape that has multiple sides, so big deal. I just want to make sure you guys understand where polygons come from. What I really want to start off today's discussion is with convex polygons versus concave polygons. So you kind of see those terms right here on the screen. So you got convex versus concave. Convex, think of like a convex lens. It goes outward from a center point. So what you see here, polygon ABCDE, is a pentagon, but it's a convex pentagon. Notice that all the points, all the vertices, point outward from the center. Okay, so all these vertices point outward from the center. And then with the concave, you have at least one point that no longer points out, it points in. So that's a concave polygon. And so sometimes you have like really neat concave polygons, right? We can have something that looks like this. Believe it or not, that although that doesn't really look like a polygon, it really is. So those are polygons that we can have within our normal system. So that's kind of some neat, interesting stuff that we can do there. So that's kind of the difference thing, again, there between concave versus convex, and now we have convex again, because all of our points are pointing outward from a random center. So that's a concave versus convex. So what I want to talk about now is normally when we do a lot of polygons within geometry, we actually talk about regular polygons. A regular polygon is unique. So we think about this. Basically, a polygon, if you really want to define a polygon, it is a multi-sided closed figure. Okay, so it's a multi-sided closed figure. So again, that basically means that we have, in this case, we have a pentagon. And a regular polygon, well, let's actually take a look at what a regular polygon is. Okay, so alright, so now we're kind of back to this whole thing about regular polygons. Let's take a look at what a regular polygon looks like. So we look at page 1.1, we have our convex pentagon, and we go to 2, and we notice that this is definitely a regular polygon. And what do you notice about this polygon? There should be some things that just immediately jump out to you. One, you should see that it's aesthetically pleasing. Your eyes naturally find this to be an appealing type of shape. Not necessarily because it's a pentagon, but basically it's appealing in terms of artistry. And so we call this a pentagon. And one thing I want you to notice, I'm going to go ahead and measure some stuff. So I'm going to measure the length of AB. I'm going to measure the length of BC. And what do you notice every time I measure? It's the same length. So what's kind of important here to learn is that in a regular polygon, all the sides are congruent. So that's a really important piece to remember from regular polygons, that all your sides are congruent. Let's go back to this. Not only are all your sides congruent, what do you think about the angle? I want you to envision angle A versus angle B. Is there a relationship there? Well, let's find out. If we go to measure angle, that ends up being 108. That's 108. So what do you notice every single time? So what we're noticing then is that all of our angles are the same as well. So this is one of those important things to remember from regular polygons, that all of your interior angles, we call them interior because they are inside the polygon. Hello. It's like, duh, you go hang out on the exterior of your house, you're in the interior of your home. So all of our interior angles are the same measure. Now it's kind of unique with this 108. We can talk about where the 108 comes from, but this is something I want to save for the discovery lesson that's going to be actually in class tomorrow. So I want to make sure that we hold off on where the 108 comes from, but it's kind of one of those really important deals. So we're going to hold off on that, but I want to go back to here. We want to write down not only are all of our sides congruent, but all the angles are congruent. By the way, what is a regular... What would you call a regular polygon that has three sides? Okay, think about that one for a minute. What would you call a regular polygon that has three sides? Well, first you should think that maybe it's a triangle, but what type of triangle? Oh, that's right, so an equilateral triangle. Okay, so equilateral is basically a regular polygon. Okay, what is a regular four-sided polygon? Okay, that's called a square. Okay, so those are some common figures you guys already know that are regular polygons. So that's some of the things that's kind of good. What I want to do now, there's one more thing I want to talk about, or actually two more before we finish this video. One of the things I want to talk about are naming angles. We'll do a little bit of time history here. Triangle is pretty obvious. Tri meaning three. Quadrilateral meaning how many sides? Quad is 4. What's the prefix for 5? Prefix for 5. Well, that's penta. So we have pentagon, hexagon. After hexa, then we have hepta, which, by the way, hepta could also be septa. One of the things I want you to do right now is, as we're going through here, I want you to pay very close attention over the next few of these. Here we go. So we have septagon, octagon, nonagon, decagon. And anything over 10, we just call it an n-gon. So if you like a 22-sided figure, we would call that a 22-gon. Okay, so that's the concept we're looking at here. But I want you to pay really close attention, but this is kind of cool. A little bit of math history here. As we go from the 7-sided all the way down to the 10-sided, that order should look familiar or sound familiar to you. Septa, octa, nona, deca. Do they sound familiar at all? Think about maybe September, October, November, December. What we can take out of this polygon lesson is actually learning about the history of our calendar. And the original calendar was a 10-month calendar. And that's why the last few months there, septa, octa, nova, and deca, are basically remnants of that original 10-month calendar. But we currently have 12 months. So, in that situation, what 2 months have been added? I'll give you a hint. We made this transition toward the end of the Roman Empire. That's all I'm going to say. Toward the end of the Roman Empire. So I want you to think about that one for a minute. Think about what 2 months were added, and where do you suppose they were added, and why do you suppose they were added? Just something to think about. Feel free to ask me about that in class. Okay. So we're going to go ahead and finish up with this. We have 2 more videos I'm going to have you guys watch. And so this is only the first series. So thank you very much.